Very good morning, students. For this lecture video session, I will teach you what do you mean by equilibrium. That means the topic equilibrium. So, equilibrium of a particle. Equilibrium of a particle. Right. So, the unit which we are in is statics of particle. What do you mean by statics, by the way? The study of the body which is at rest. Right. So, just observe carefully what I am going to do here. So, assume a body. Assume a body. It is at static condition. That means it is at rest. Now, going to apply some forces. So, in place of this body, I am going to keep a rectangular body. Okay. So, it is the surface. Over the surface, a body is being placed. Now, it is in the static condition. That is nothing but the rest condition. Going to apply forces. So, it's some forces here, some forces here, right, and right, few forces have been added, that is the external force have been applied on this object or the particle. What will happen? The previous stage was the object was at rest. Now, when few forces have been applied on this body, what will happen? Right. So, look at here. This is a force, right? So, now this becomes the resultant force may act. This is only assumption. This may act in this direction. This is only assumption. For example, this one has F2, F3, F4, F5, F6. This is W. Right. So, all the forces have been replaced by a single force, which is the resultant. Right. What is the meaning of resultant? When several forces are acting on a particle or replaced by a single force, right, which could produce the same effect as produced by the given forces, then that single force is called resultant. So, here this same thing is happening. So, several forces are acting on the body. Ultimately, a single force which is being represented as resultant. What happens here? Because of this resultant, it causes the unbalance in the system. Whereas the topic we are in is static condition. Right. In order to bring that as rest, due to this resultant, this body may move to either in the positive x direction or in the positive y direction, isn't it? So, in order to bring this system in a stable condition or in the rest position, we need to apply a force which should be of same magnitude of this resultant and should be in the opposite direction. Right. So, that is equilibrium. The definition of equilibrium is the force which brings all the forces in equilibrium is called equilibrant. So, equilibrant is equal to the resultant force in magnitude but opposite in direction. And its line of action which acts along the resultant. So, assume this is resultant, right? So, now I am going to add a force of magnitude of the same magnitude of the resultant but opposite in direction. This force which brings the system in equilibrium condition, though it is called equilibrant. Right. Then what do you mean by equilibrium? A particle is said to be in equilibrium when the resultant forces, that means resultant forces of all the given forces acting on it is 0. Correct? So equilibrium means, let me just write it down here. Equilibrium means a particle is said to be in equilibrium when the resultant of all forces, acting on it means on the particle, is 0. Right? Then what do you mean by equilibrant? Equilibrant. The force which brings the set of forces in equilibrium is known as equilibrant. This equilibrant is equal to the resultant force in magnitude and opposite in direction right, and its line of action is along the resultant force. Look at here, this is the resultant where the line of action of the force, the equilibrium, act in the same line of action. So this is the equilibrium and equilibrant. So the condition of equilibrium shall be when the resultant becomes 0, then what will happen? The condition or the necessary or the suitable conditions, right? The equilibrium condition. Equilibrium condition of a particle in 2 dimensions. What did I tell you? Equilibrium becomes, that is, a body is said to be in equilibrium when all the resultant force acting on the body becomes 0. That means R is equal to 0. What is the formula which I taught in the resolution of forces? R is equal to root of summation of h square plus summation of v square. When R is equal to 0, what will happen? Summation h will also become 0. Right? So R is equal to 0, summation h is equal to 0, and summation v is equal to 0. Got it? Right. So that means the summation h is nothing but this algebraic sum of R is nothing but the magnitude of resultant, and summation h is algebraic sum of horizontal forces, right? Algebraic sum of horizontal components or horizontal forces, where summation v is equal to algebraic sum of vertical component or vertical forces. When summation h is equal to 0, which means forces acting, the horizontal forces which is acting in left hand side is equal to forces acting in right hand side. Right, as I taught you, if this is plus x, this is plus y, this is minus y, this is minus x. Look at here, what this statement says, forces acting in the left hand side is equal to the forces acting in the right hand side. Suppose a force is acting here of 20 Newton and a force is acting in this direction 20 Newton. When you calculate the sum of horizontal forces, you will take this as positive value and this as negative value. When you just sum it, you will get 0. That's what it says here. Similarly, summation V equal to 0. That means forces acting in vertical upward direction is equal to the forces acting in vertical downward direction. Vertically downward direction. Suppose for an example, the magnitude of a force which is acting in the positive y direction is 10 Newton, and in the negative y direction the magnitude of 10 Newton. What will happen? If you just sum of all the algebraic, that's the algebraic sum of vertical forces, if you just calculate it, plus 10 minus 10 becomes 0. That what is specified here. So, in nutshell, the equilibrium condition of a particle in two dimension means R is equal to 0 and summation V is equal to 0 and summation H is equal to 0. This is what equilibrium condition of a particle. Hope you have understood the concept of equilibrium and equilibrium. With this concept, I will just solve a few problems in the upcoming videos. Thank you.